Hello everyone, how are you? I hope all are fine and fit. Take care of yourself, stay protected, stay safe from coronavirus, and enjoy learning. As we all know that we cannot allow this coronavirus pandemic to affect the learning of our students. So keep enjoying learning. With this, let us start with our today's session. But before starting it directly, just observe the pictures in front of you on the screen and tell me what you are going to learn today. Any guesses? Yes, correct. We are going to start with the chapter that is motion. So we observe many objects in our day to day life which are at rest and others in motion. So, before starting directly, let us understand the concept of motion and rest in detail. So, we see many objects like a book lying on the table, a bench fixed in a park, birds fly, fish swim, blood flows through veins and arteries, car moves, atoms, molecules, planets, stars, and galaxies. These are the examples where the objects are at different states. Now, with this, let us understand what is the difference between the objects which are at rest and the objects which are in motion. So, we can say that a body is said to be at rest if its position does not change with respect to a fixed point in its surrounding. For example, book lying on the table, a bench fixed in a park. The bench in the park is fixed related to the trees, the water which is present in the pond. Whereas we can say a body is to be in motion if its position is continuously changing with respect to its surrounding with time. For example, a flying bird, a boy playing the football. So we can say that the state of rest and motion of the body is relative to each other. The body can be both at rest and in motion at the same time. We often perceive an object to be in motion when its position changes with time. However, there are situations where the motion is inferred through indirect evidences. For example, we infer the motion of air by observing the movement of dust and the movement of leaves and the branches of trees. Then tell me what causes the phenomenon of sunrise, sunset, and changing of seasons? Is it due to the motion of the earth? If it is true, why don't we directly perceive the motion of the earth? An object, it may appear to be moving for a one person and stationary for some other. For the passengers in a moving bus, the roadside trees appear to be moving backward. A person standing on the roadside perceives the bus along with the passengers as moving. However, a passenger inside the bus sees his fellow passengers to be at rest. What do these observations indicate? It indicates that motion is a complex term. Most motions are complex. Some objects may move in a straight line, others may take a circular path. some may rotate, and a few others they vibrate. So, there may be situations involving a combination of these. So, in this chapter, let us first learn to describe the motion of object along a straight line. With this, the topics which we are going to cover in this today's session are uniform motion and non-uniform motion, measuring the rate of motion, that is subtopics are distance, displacement, speed, velocity and acceleration. So first we will learn to express such motions through simple equations and the graphs in the next lecture. So let us start with describing motion of an object. So we can describe the location of an object by specifying a reference point. Let us understand this by an example. Assume that a school in a village is 2 kilometers north of the railway station. We have specified the position of the school with respect to the railway station. So in this example, railway station is the reference point. So whenever we are describing any type of motion, we need to describe it with specifying a reference point. Therefore, to describe the position of an object, we need to specify a reference point, that is also known as origin. So let us start with the motion in a straight line. It is the simplest type of motion. We will learn to describe this by an example. For that, consider the motion of an object moving along a straight path. The object starts its journey from O, which is treated as its reference point, whereas A, B, C, these represents the position of object at different instances. Now, at first, the object moves through C and B and it reaches A. Then it moves back along the same path and reaches C through B. Now here in this case, the total path length covered by the object is OA plus AC, and the distance between OA is 60 km and AC is 35 km. Therefore, the total length which is covered by the object is 95 km. This is the distance covered by the object, and to describe the distance we need to specify only numerical value. We don't need direction. There are certain quantities which are described by specifying only their numerical values, and the numerical value of physical quantity is its magnitude. So here 95 is its magnitude. From this example, can you find out the distance of the final position C of the object from the initial position O? So this difference will give you the numerical value of the displacement of the object from O to C through A. That is, the shortest distance measured from the initial to the final position of an object is known as the displacement. So let us understand what is the exact difference between the distance and the displacement. For that, consider one example. Consider school and home as 2 points A and B. Now, measure the distance between the school and home in different ways, like which is shown by these red line and here this green line. Now, measure the distance along the blue ray or the blue arrow. Which distance is correct according to you and why? Now, we have already seen that the distance is the actual length of the path traveled by a moving object, and displacement is the shortest distance between the initial point and the final point of the object. So here you can go to school from the home along this red line or along this green path. You can choose any path. So whatever actual distance you are going to travel, let us consider you have traveled a distance of 1 kilometer along this red path, and green, suppose through green path you have covered a distance of 2 kilometers, then that is going to be your actual length of path which is traveled by you, and that is the distance. So to specify the distance, we don't need direction. Yes, whereas if you want to go from home to the school, and if you will choose this shortest path along this blue arrow, that is your displacement, because that is the shortest distance between the home and the school. Here, the direction has to be specified with respect to the reference line, and therefore distance is a scalar quantity whereas displacement is a vector quantity. Now use your brain power and tell me, can the magnitude of the displacement be equal to the distance traveled by an object through these two examples? In first example, every morning, Swarali walks along the edge of a circular field having a radius of 100 meter as shown in this figure 1.2a. If she starts from the point A and takes one round, how much distance has she walked and what is her displacement? Can you guess the answers? Let us consider the next example. If a car starting from point P goes to point Q as shown in this figure 1.2b and then returns to P, how much distance has it traveled and what is its displacement? So in the first example, distance traveled by Swarali is equal to 100 meter, whereas her displacement is 0 because she is starting from point A and again reaching to the point A. Hence, the displacement is going to be 0. In the second example, the distance traveled by the car is 360 plus 360 because it is starting from point P, then goes to point Q, and again it returns to point P from the Q. So the actual path which is covered by the car is 720 meters. Whereas, what is its displacement? So obviously the displacement is going to be 0 because the car is starting from point P and again it reaches point P. So displacement is going to equal to 0. So even if the displacement of an object is 0, the actual distance traversed by it may not be 0. Now I hope the concepts of distance and displacements are cleared. Now let us learn the concept of uniform and non-uniform motion. Before that, observe this table. There are two objects, object A and object B. And the distance traveled by object A and object B is given in this table with respect to the time. So here we know the data regarding the motion of two different objects A and B. Now examine them carefully and state whether the motion of the object is uniform or it is non-uniform. Take some time and just observe it. So in this example, the time interval is constant, that is of 15 minutes. If you will observe the distance traveled by object A, then object A is traveling a distance of 10 meter in given interval of time. Whereas if you will observe the distance traveled by object B, then the distance traveled by this object B is different in a given time. For example, between 9:30 to 9:45 am, the difference between the distance, if you will see, that is of 7 meter. In next 15 minutes, the difference is of 4 meter. In next 15 minutes, the difference is of 12 meter. So everywhere the distance traveled by the object is changing. So we can say that if object travels equal distance in equal interval of time, then that object is said to be in uniform motion. Whereas if the distance traveled by an object is unequal in equal interval of time, then it is said as non-uniform motion. If we will consider the graph between the distance and time for a body having uniform motion, that is straight line. Whereas if you will consider the distance time graph for a body having non-uniform motion, then it is curved. Examples are given: a car running at a constant speed of 10 meter per second. It means car covering a distance of 10 meter per second. So its motion will be uniform motion. whereas the motion of a freely falling object is an example of non-uniform motion, or the motion of a vehicle being driven through heavy traffic is also an example of non-uniform motion. So we can say different objects may take different amounts of time to cover a given distance. Now, let us consider these two situations. If the bowling speed is 143 km per hour, what does it mean? What do you understand from the signboard in the another picture? Yes, so some of them move fast and some move slowly. That means the rate at which object move can be different. Also, different objects can move at the same rate. One of the ways of measuring the rate of motion of an object is to find out the distance traveled by the object in unit time. So, we need to find out the ways of measuring the rate of motion. First is the speed. Speed is the distance traveled by an object in unit time. Its SI unit is meter per second. Its CGS unit is centimeter per second. As well as we can measure the speed in kilometer per hour. Now, to specify the speed of an object, we only require magnitude, hence speed is the scalar quantity. Now, the speed of an object need not be constant. There are most cases where objects will be in non-uniform motion. Therefore, we describe the rate of motion of such objects in terms of their average speed. So we can say average speed is equal to the total distance traveled divided by the total time taken. We can say the speed is related to the distance. Let us understand the concepts of speed and the average speed with the help of this example. Just look at this figure. So what do you observe in this picture? Sangeeta's house, Sheetal and Prashant's house, and the school, right? So in this example, the straight line distance between the house of Sheetal and Sangeeta is 500 meter, and that between Sangeeta's house and school is 1200 meter. Also, the straight line distance between Sheetal's house and school is 1300 meter. Suppose Sheetal takes 5 minutes to reach Sangeeta's house and then 24 minutes to reach school from there. Then what is this Sheetal speed along path A? So the speed of Sheetal along path A is equal to distance traveled by Sheetal in the time required to cover that distance. which is equal to 500 upon 5 minutes, which is equal to 100 meter per minute. Now, Sheetal's speed along the path B is equal to distance upon time, which is equal to 1200 divided by 24 minutes, which is equal to 50 meters per minute. So Sheetal can directly reach the school either passing through Sangeeta's house, then to the school, or she can directly go to the school by covering the shortest distance, that is 1300 meter. So let us find what is Sheetal's average speed. So here the Sheetal speed along path A and B, that is the total distance travelled by Sheetal along path A plus distance travelled along path B, divide by the total time required along path A plus path B, which is equal to 1700 meter divided by 29 minutes, which is equal to 58.6 meter per minute. We'll take one more example so the concept of average speed will get cleared. A car travels a distance of 100 km in 2 hours. So, its average speed is going to be 50 km per hour, because the car might not have traveled at 50 km per hour all the time. Sometimes it might have traveled faster and sometimes slower than this, and because of this we need to calculate the average speed of the car, as the motion of the car is non-uniform. So I hope the concepts of motion, the object which is at rest, as well as the motion along a straight line, the uniform motion and non-uniform motion, measuring the rate of motion in that speed and the average speed, these concepts are cleared. If you have any doubts and queries, feel free to ask again. Now get up and wash your hands for 20 seconds. Stay safe and stay away from coronavirus. Thank you so much. Let's meet in the next section with new topics. Bye.